All right, so our next type of forces, dispersion were the weakest, they're the temporary ones. Our next type of forces are your dipole-dipole forces. They are stronger, and that's most notably because they're permanent. So these are permanent dipoles. Again, dipoles, two poles, have a positive and negative end. Very good example is if we take a look at hydrochloric acid, HCl. Obviously, HCl has 1. A chlorine would have 7 valence electrons. Therefore, you could have a sharing. So HCl. Now, due to differences in electronegativities, hydrogen has a 2.1, chlorine has a 3.0. Then, therefore, we have polarity. And that polarity will be towards chlorine. So because of that, hydrogen has a partial positive, chlorine has a partial negative. It's not a loss or gain, but rather just a polar covalent bond. Okay, so again, these are covalent bond. Okay, so notice these partial charges. Well, these are consistent, they're permanent. So therefore, if you have that H with a Cl, oops, I kind of put an extra valence, and we have this partial positive, partial negative, if another HCl is near the first, then you're going to have, of course, or I should say of course, but partial positive, partial negative on this one. Okay, and if you look at the red one, it's going to go the opposite way, partial negative, partial positive, which creates these attractive intermolecular forces. So you have the H on one, which is partially positive, and the Cl on a second, which is partially negative, have these attractive forces. They're not bonds, they're not connected, but they're attracting each other. Think of it as two magnets and holding them, not touching, but rather together. You can kind of feel them pulling closer. So what happens is with these intermolecular forces, you have either stronger ones, depending on what the dipole-dipoles are, what the makeup is, but basically, let's say we have a molecule, okay, and we have these molecules all over, okay, we can create these little attractive forces, okay, and it holds these molecules much more tightly compact. Hence the fact that often most dipole-dipoles might be liquids at room temperature, because it keeps the molecules, since it's an intermolecular force, not a combination, not a bond, but an intermolecular force that's permanent, so therefore it kind of holds them in place. They may be able to move, and certainly some dipole-dipoles have gas molecules. But that's what a dipole-dipole, it's permanent dipoles. I'm going to move on to the next one real quickly. I don't want to spend too much time on it, and you'll see why in just a moment. But the last type of intermolecular force I want to talk about is these hydrogen bonds. And you might see my head might be cutting off over here, but it basically says hydrogen bonds or forces are the same as dipole-dipole forces, but it involve hydrogen. So I probably didn't give a very good example with the dipole-dipole because I used hydrogen. That would have had some hydrogen forces in it with the HCl. I wasn't thinking ahead, but hydrogen bonds would be this. So this HCl example I just gave you would be a good one for a hydrogen bond. It's the same type of forces. It creates those permanent dipoles, and they involve hydrogen. Water is another example. I was thinking of using water as my example for the hydrogen one and didn't think much about it when I used my dipole-dipole. But because you have these unequal charges, partial negative, partial positive, then when another water molecule, partial positive, partial negative, you get these attractive forces here. All right, stronger than dipole, straight dipole, because hydrogen's very small. The electron, there's only one electron. It's located very close to its nucleus, proton. So therefore, it kind of shrinks. There's not as much room, not as far apart. So therefore, these forces are a little closer, and it can be a little bit stronger. So your weakest type of intermolecular force are your dispersion. Secondly would be your dipole-dipole, and then hydrogens are the stronger of the two. Hopefully I didn't confuse you by using HCl as a good example for dipole-dipole. Understand that that would be a hydrogen
bonded or hydrogen forced type of intermolecular force. Those are your intermolecular forces. We'll move on with the next slide in one more minute.